Okay, hi guys, welcome back to the channel. Today we're going to be going through my predicted paper for paper 1. This will be higher tier. It is, I've written this based off of looking at all of the Edexcel past papers for paper 1. So this is kind of, I mean, it would work for obviously AQA and other things, but it's basically mostly focused on Edexcel, as usual. So it's just, I've gone through all the past papers, seen which topics seem to be the most common. Again, this is a prediction. I'm not saying that this is what will come up. I'm not saying that other topics will not come up, because they definitely could. It's obviously very unlikely that I am 100% right on all of the questions, right? So that's why I've written this disclaimer. Please obviously don't use this solely as your own revision. I know most of you are obviously revising outside of this anyway, but definitely make sure that you are revising everything, because you just don't know what will come up really on a paper 1. It could literally be anything. This is just my guess. I've tried to replicate obviously the fact that obviously it should be 80 marks. I've tried to kind of make it roughly about the same amount of questions as normal, as much as I can. And yeah, hopefully you find this helpful. So question 1, from what I've seen of Edexcel, there's 9 times out of 10 there's always going to be some kind of fractions question, particularly though with mixed numbers. I feel like they do that quite a lot, so that's why I've done mixed numbers as well. So when we're subtracting fractions, first of all I'm going to convert them into improper fractions. You don't have to do that for adding and subtracting, but I just prefer to do that for adding, subtracting, multiplying, dividing. Keep it simple, keep it the same method. So converting them into improper fractions, we need to do 4 times the denominator, which is 8, plus the 1, so that's obviously, oh, why is my pen so big? Hang on. That's obviously 9 over 2, isn't it, for that one? And then minus 2 times 3 is 6, plus 2 is 8 over 3. Now, obviously then we are going to subtract. You need to have a common denominator. That would be 6. You can obviously use 12 or any other multiple, but we'd ideally want the lowest common multiple, which is 6. So the first one we'd have to times by 3, top and bottom, and the second one obviously then by 2. Now I'm going to subtract, obviously just subtract the numerators, so that should give you 11 over 6. However, they do say give your answer as a mixed number, so I'm going to convert it back. Just double check on your question in the exam if it wants it converted back. If it doesn't, if it wants it simplified, just double check. So obviously 6 would go in once with a remainder of 5/6. That would be the most simplified answer. Now that's how I do it. You might do it a different way, as long as you get the 1 and 5/6 at the end. Because it does say give it as a mixed number, if you left it as 11 over 6, you wouldn't get the 2 marks, right? It has to be a mixed number at the end, just because in the question I specified that. So yeah, you might have subtracted the 4 and the 2 and then subtracted the fractions separately. That's also fine. Let's see, what did you get? You're 1 and 21 over 40. I'm not sure where the 40 denominator came from. 2 and 3. 2 obviously goes into 40, 3 doesn't though, so it's not a common denominator. So I'm not sure where that came from, the 40 denominator. Yeah. Oh, okay. That's fine. Let me make sure that you get the same answer. 2 over 3. Yeah, 11 over 6. 1 and 5/6. Are you guys doing a different paper? Oh, have I uploaded the wrong one? Hang on. Because I changed the question after, because I didn't really like that previous answer. Wait, I must have done the wrong one. Hang on, give me a second. I changed question 1 and question 2b. The rest is I think the rest apart from the last question is the same. So yeah, hold on a minute. No, yeah, I changed it because I didn't really like the answer. It was kind of an ugly answer. Did I upload the wrong one? That's so bad. Where is my... Give me a second, guys. I'll swap it for you. Thought I'd put the right one in there. Yeah, because then the mark scheme won't match for what you've... Yeah, that's the old one. Okay, give me 1 second to change it. Annoying. Okay, let me delete that. Upload. Strange. Right, that's the mark scheme. Sorry, I'm just sorting it out, guys. Give me a few seconds. Upload. Yeah, I changed question 2b because it was too long. Exactly. I looked at it and I was like, nah, this is not a good example. So I swapped it. The actual one that we're about to do will be different. So I changed question 1 mostly because I just didn't like it, and question 2b because it was too long. And that was my second version. There we go. Okay, I've swapped it. If you go back onto that file, have a look. As I said, the rest of them, it's just question 1, question 2b that's swapped. And also I think I changed the last question just slightly to make it work, but the rest of the questions are the same. Yeah, the 1 and 21/40, yeah, that was my original question. Yeah, that was right. But yeah, sorry about that. Yeah, open the rest. The rest should be the same. It's just those first 2 questions I just adjusted slightly when it worked through it and thought, actually, no, this is not very good. Okay, let me know when you've got the new version up, and then we can carry on. You got it? Yeah, everyone just let me know when you're ready and I'll carry on. Question 2a is the same. It's just 2b that I swapped. And yeah, that should match with the mark scheme as well. Yeah, okay, perfect. All right, so yeah, I don't know if you want to go through question 1 again, see if you've got the same answer, or if you're happy to move on to question 2. Okay, I'll move on to question 2 then. So multiplying decimals, I like to convert them into whole numbers. So the first one I would obviously multiply just by 10. Second one I would multiply by 100. Again, just because I do it this way, if you get the same answer and you do it a different way, that's fine. So that would be, and then I would use column multiplication, right? So I'd list them like this, 431 and 84. So we're multiplying first by the 4. So 4 times 1 is obviously 4. 4 times 3 is 12, so obviously you put the 2 and you carry the 1. 4 times 4 is 16, so that would give you, obviously then, 16 plus 1, which is 17. The 1 just goes there. You can carry it if you want, or just write down the 1. And then, obviously, then I'm going to go to the 8. Now, because the 8 is not just 8, it is 80, you put a 0. 8 times 1 is 8. 8 times 3 is 24, so 4 carry the 2. And then 8 times 4 is 32, plus the 2 is 34, isn't it? So you get that, and then I would add them. So the last digit is 4. This becomes obviously 10, so carry that 1. 11 plus 1 is 12. Carry the 1 again. 1 plus 4 plus 1. Just be careful with... I guess I should probably put the 1s in the other place. Put the 1 here. 7 plus 4. That's a horrible one. What's going on there? 7 plus 4 is 11, plus 1 is 12. Carry the 1. That's 6. And obviously the 3. So, yeah, you got everything just the last digit. I guess you maybe just times it by 1 instead of, like, 1 by 1 instead of 1 by 4. Now, obviously, you have to scale it back. There's different ways to do that. Normally, I just say, well, how many times did I move the decimal places in total? Do you see how I moved it once here, twice, 3 times? So I just move it back 3 times. Or you could think of it as dividing by 1,000 because you've got 10 here and 100 there. 1, 2, 3. Or the other way is just thinking, this one's not as obvious, but sometimes if you just think about, this is kind of like roughly 80% of 40, for example, that's going to be something near to 30, isn't it? So however you want to work out the scale, just remember to scale it back. Okay, so 3 marks. So obviously 1 mark is the answer. The 2 marks would be within this. So I think probably 1 mark for the multiplication and then 1 mark for adding, if that makes sense. I've obviously chosen the marks based off of what I saw from the actual past papers as well. I've chosen, so they awarded 3 marks in the questions that I've seen on decimal, so I also put 3 marks. Like, I haven't just made it up, I've tried to copy what they've done, just to make it as accurate as I could. Obviously it had to add up to 80, so there's probably maybe 1 or 2 questions where I would have maybe given more marks, but you know, I've tried to replicate it as much as possible. Yeah, if you look at the part, like an actual past paper question on this, they've said 1 mark is for the method. The 2nd mark they've said is for getting these digits. So I guess the adding bit, the 3, 6, 2, 0, 4. And then the 3rd mark is for putting the decimal place in the correct place, if that makes sense. So that's how, if you look at an actual past paper, that's what they've said. So yeah, question 2, I would scale this one as well. Now it's up to you how you scale it. Yeah, they said 3 marks. I've copied that from a past paper. They've given 3 marks for each, which I think is quite nice. So I would scale this when I'm dividing. I personally like to scale them both by the same amount. You might want to just scale it, you know, by 100 and then by 10. It's up to you. If you scale it by the same amount, then you don't have to scale it back at the end, if that makes sense. So it's up to you. So I scaled it. Obviously, the first one has to become 735 to make it a whole number. Then I made this one also. I times it by 100 as well. You might think that that's unnecessary. You might want to use 25. That's fine. But then at the end, obviously, yeah, exactly, you'd have to figure out the scale at the end. So this is just personal preference. This is the way that I did it. So I just went, well, it's obviously still the 25 times tables. You just add a 0. So obviously goes in twice to 735. You then got 200, well, in my case, 235 remainder. In your case, you might have, 23 as your remainder, and then it would make 235, if you see what I'm saying. So then I just knew that 25 or 250 goes into 2008 times, so it was 9 times with a remainder of 100. You might have had a remainder of 10, for example. It just depends. And then obviously that's 1,000, so it goes in 4 times, and then that's it. So in my case, I didn't have to scale it down at the end because I scaled them both by the same amount. If you scaled it separately, yeah, 735 divided by 25, that's fine. If you want to just do it as the decimals, that's also fine. As long as you get the same answer, it really doesn't matter. And again, so they've said 1 mark for the method to divide, and as long as you get like the first digit, so like the 2. The 2nd mark is to get these digits 294, and then the 3rd mark is to put the decimal place in the correct place. Yeah. If you've changed it only 1 by 100, 1 by 10, you'd have to scale it at the end. Yeah, because you've scaled them separately, so you'd have to scale it back. But yeah, as long as you get 2.94, that is the answer. 6 marks for that question, which I think is quite nice if you just memorize how to do it. What's the best way to get the bigger number times table? Oh, hang on. To get the bigger number times table. What do you mean by the bigger number times table? Are you referring to this question or the highest common factor question, or? You mean like figuring out the times tables, or like knowing the times tables are bigger numbers? Is that what you mean? To find the, oh, like as in, for example, 25. Because I mean, naturally we wouldn't know 25 times tables. I don't know. I mean, 25 I just kind of recognize just from experience, I guess. Like I know, and obviously then I just add a 0 to make it the 250. I don't know, 25 I just know the multiples is like 50, 75, or 750 if it's 250. Like I know that 25 goes into 100 4 times, so obviously 250 goes into 1,000 4 times. Do you know what I mean? I don't know. I mean, I guess if it was a different number, it would be hard. Like if it was like 26, then yeah, I would be guessing a bit more. I would have to just literally work it out. Maybe if you're dividing, it's helpful to write down some multiples of that times tables before you start. That could help. Yeah, the zero, obviously the 0 at the end, it's just obviously that same exact times tables with 0 on the end. I've always said for paper 1 to maybe recognize some of the 15 and 16 times tables, because I think that comes up a lot. So that one I would just maybe learn a few of those, become familiar with it. But I don't know, some of it you just have to work it out. I don't know how to. It depends on the number, doesn't it? If it's like kind of one that's easy to recognize, if it's just a random number, you'd have to kind of figure it out. So yeah, question 3, highest common factor. They'll either ask some kind of highest common factor, maybe lowest common multiple, or just the product of prime factors. Kind of one of those. I went with highest common factor. The way that I work it out is I break it down into the factor trees and do the Venn diagrams. If you did it a different way, that's fine, as long as again we get the same answer. So I would do 252. Some people think this is longer, but I don't know. I just feel like it's a more solid method to make sure I don't make any mistakes. So 2 and then 126. I just start with 2 if it's even. Just keep breaking it down in half and then it gets smaller quite easily. Obviously after then you can't do 2 anymore. I check 3 or 5. That one does 3. 3 and 7. And then this one, obviously not even, so I start with 5, 21. I mean, you can kind of see what the answer is already, but just to go through the whole method, this is how I would do it. So just scribble some circles, they don't have to look nice. This works, I think, quite well for lowest common multiple, more so, I guess, because it saves you from having to do the times tables. So obviously, what do they have in common? They both have a 3, they both have a 7. You could fill out the rest of the diagram if you wanted, but technically, for highest common factor, it's only ever the middle, isn't it? So you don't have to. You could just leave that and go, well, that's the only thing in common. So obviously, I'm going to multiply those, and as you've all said, you get 21. Again, if you do it a different way, that's absolutely fine. I just prefer to use that way. I think for lowest common multiple, it's easier to do it this way if the numbers are quite big, because then you don't have to figure out the times tables. But it's up to you. As long as you got 21, then that's fine. Okay, so that's quite a nice question as well. There's normally, I feel like, some kind of what I would class as general arithmetic questions. So what I mean by that is just kind of multiplying, dividing, adding, subtracting. It's got like a context. It's got some fractions, maybe percentages, ratios, that kind of thing. There's normally some kind of question like that, isn't there? Okay, so Kai's organising a charity bake sale. He bakes 120 cupcakes. He sells 3/5 of the cupcakes in the morning, so we want to work out that. When we're working out fractions of an amount, we divide by the denominator times by the numerator. The way that I divide by 5 is I divide by 10 and then double it, but you can obviously divide however you want, so that would give me 24. 24 times 3, I just did 20 times 3, which is 60. 4 times 3 is 12, so 72. Again, multiply it however you want. So this is how many he's sold in the morning. And then in the afternoon, he sells 25% of the cupcakes he has left. So I have to work out how many's left. So obviously I'm going to subtract. So that would be takeaway 70 would be 50, takeaway 2 is 48. So that's how many he has left. So then 25% of that, I basically just work out a quarter, because 25% is a quarter, isn't it? You can work out 25% however you want, but I basically just do 1/4, so divide it by 4, which is 12. So that's how many he sold, and then the remaining cupcakes are shared. So again, I want to take that away, don't I? So that was you don't have to write these words, but I'm just kind of doing it so you can see what these numbers are. That was the afternoon. So how many he has left after that is obviously 36, isn't it? And then that's what is shared between Emma, Connor, and Maria in the ratio. So we need to add those up. That gives you 9. So sharing out a ratio, divide by how many there are. And then we only want to work out how many cupcakes Maria receives. So you don't have to work out Emma and Connor. You can, but you don't have to, so there's no point. So I would multiply that by how many parts Maria has. Obviously, it's in order, right? In order that they write the names. So 36 divided by 9 is obviously 4. 4 times 4 is 16. So you should get 16. Yeah, you should get 16 as your answer. You got 8. Not sure where you got the 8 from. I mean, maybe one of the divisions, because it's like a multiple of 16. Well, 16 is a multiple of 8, isn't it? So maybe somewhere. Yeah. Maybe just double check to see where you missed something, I guess. Okay, that one. This one I put 4 marks. To be honest, I would suggest it's probably 4 or 5 marks. But again, I was trying to make it add up to 80. So this one's about 4 or 5 marks, you could say. Oh, okay, that's fine. So 16, about 4 or 5 marks, roughly. Question 5. I feel like there seems to be a lot of speed, distance, time in the non-calculated papers for Edexcel for some reason. So Sadie wants to run 6 miles in 45 minutes to hit a new PB. Work out Sadie's average speed in order to achieve the PB. And it does say give your answer in miles per hour, right? So that's the thing, you have to make sure that all of the units match, because if you've got your answer in miles per hour, we've got the distance in miles, so that's fine. But do you see the time we've been given in minutes? No, it's not 70 in the morning, it's 72. Because 3 times 24 is 72, yeah. Okay, so just be careful with these, and not just speed, distance, time, but any of the ones where you've got the formula triangle. So, you know, when you've got pressure, force, area, when you've got density, mass, volume, you have to make sure that whatever the units they want do match up with all the pieces that you're going to sub in. So obviously, speed, distance, time. We're looking for speed, we're going to do distance over time. So first of all, I'm going to convert the time into hours. So if you want to convert any minutes into hours, you always divide by 60. Now this one you probably already know what it is as a fraction anyway, but that would simplify to obviously 3/4 of an hour. You could use 0.75 if you want to use a decimal, that's fine. I would rather use a fraction. So then obviously speed is 6 divided by 3/4, which is, you could, because I've used a fraction, we can obviously do keep, flip, change. That's why I chose to use a fraction, but however you prefer to do it, as long as you get the same answer is fine. 24 over 3, which is, as you've all said, 8. Yeah, exactly. 45 minutes is 3/4 of an hour. That's fine. Yeah, you're right. That's fine. 6 divided by 3/4, exactly. You should get 8. Okay, so I mean, speed, distance, time is fairly straightforward. It's just making sure that you've got the units as well. Oh. Not gonna line up? No. Okay, that's fine. So obviously, non-calculator, you have to have memorized the trig values, so that's where this will come in. So ABC is a right-angled triangle, work out sides of angle ABC. So that's obviously this one here. So we're going to label it. I just tend to label 2 of the sides, obviously the 2 sides that are relevant. So in this case, the 2 that are labeled. So obviously the 7.5 would be the adjacent. And then the 15 is obviously the hypotenuse. So I only label 2 because then when I think of SOHCAHTOA, it tells me which one obviously I need to use. Obviously in this case, it would be cos. I might already know the formula, but I like to write the triangle anyway. So because we're looking for the angle, I'm obviously crossing out the cos bit. So we've got cos of the angle ABC is the adjacent over the hypotenuse, 7.5 over 15. Now this is more just recognizing the numbers. Yep, cos, exactly. Because hopefully you just recognize that 7.5 is half of 15, isn't it? So that would become a half. Now, this is the bit where you would need, obviously, normally in a calculator, you would do cos inverse of a half, wouldn't you? This is where you've got to use your table of values, the ones that hopefully you've memorized. You'd have to go, well, based on my table of values, obviously for cos, which angle is the equivalent of a half? It's kind of like using the table backwards, isn't it? Yeah, exactly. So you put 60. So you would just have to make that link, if that makes sense. You'd have to go, oh yeah, I know that cos of 60 is a half. So therefore, my answer is 60. So they could ask you it that way round. Okay, so that one's just 2 marks. Yeah, exactly. Once you've learned it off by heart, you just, figure out in your head which one of that table it is, isn't it? So that was a fairly straightforward question. It's just converting it at the end, I guess. Question 7, there's obviously always some kind of indices, isn't there? Index laws, things like that. It's okay if you haven't memorized it yet, if you just memorize it a few days before. Whatever works for you. Some people like to memorize it, right the night before. Some people like to memorize it ahead of time. It's up to you. So the first one, you could probably just figure it out. I mean, you would normally add them. The way that I kind of just did it, you don't have to write it like this, it's only 1 mark, isn't it? But just to kind of over-explain it, is technically that's the equation, isn't it? So if you solve it, you get -2. Yeah. So you don't have to write that down. I'm just kind of showing you where that comes from. Obviously 5 plus -2 would give you 3. Now, part B, this one comes up a lot. Obviously, I've chosen 18 as a random number. It will be a random number. But anything to the power of 0 is always 1. So don't put 0. It is always 1. And then part C is our negative indices. So negative power is where we take the reciprocal. So obviously that's 1/3. And then to the power of 4, again, you don't need to write that. It's only 1 mark, but just to kind of show you. I would recommend memorizing 3 to the power of 4. Just be familiar with it. It's 81. It's obviously the same as 9 squared, isn't it? 0 to the power of 0. 0 to the power of 0 you couldn't do. That does just give you an error on the calculator. So they won't give you 0. But any other number they could give you, obviously they could give you a letter as well. Like sometimes they might put what is y to the power of 0. It's still 1. Anything to the power of 0 is 1. Obviously they wouldn't give you 0 to the power of 0. Because that just doesn't work, it's invalid. Because you can't really get a 1 from everything being 0, can you? Think about it that way. So yeah, just a few different questions there. Question 8, there's normally some kind of angles question, whether it's parallel lines, whether it's kind of triangles, some kind of fairly straightforward angles question I feel like comes up quite a lot. So here we've got, the diagram shows triangle PQR. Triangle PRS is an isosceles triangle. As you can see, I've drawn the little lines as well, so you can see that. And then we've been given another ratio, so the size of angle PQS, so that one, to the size of angle QPS is 2 to 1. Now, I just label it as this, you don't have to. I just labeled it like that. So work out the size of angle PQS, so this one here. Obviously, being an isosceles, and also the only thing we know is 63, we're going to start there. We need to know, based on being isosceles, that this one is also 63, isn't it? Then what I did was, obviously, I want to get into the next triangle, so that's angles on a straight line, isn't it? 180 minus 63 gives you 117. And then the 117 can be subtracted again from 180 to find the rest of that triangle. The other two angles would obviously be 63 degrees, wouldn't they? So then you can either share out your ratio just normally by adding it to make 3, or you can use the algebra that I've done. It doesn't matter how you lay it out. So x is 21. Now, the only thing with that is that obviously we want to know 2x, don't we? So you just have to remember at the end, you want to know the side of the ratio that has the 2 parts. So the 2x is 42. So your actual answer is 42. So 3 marks. 42. Okay, so just a pretty nice kind of just angles one there. Question 9, obviously we want to know how to do percentages without a calculator, but more specifically what I'd call reverse percentages. So the price of a phone is reduced by 30% in the sale and now costs £294. Find the original price. So the way that I think about it, obviously I would do this differently if it was calculator, but given that it's non-calculator, this is how I'd do it. £294 is the equivalent of actually 70% of the original, isn't it? So then I go, well, how do I get 10% from that? We're not dividing by 10. We don't want 10% of the 294, right? We want 10% of the original price. So obviously I would divide, in this case, by 7. You'd obviously choose whatever digit they've given you. So 294, you'd have to divide by 7, however you want to divide it. I just did it in bus stop. So that would be 4 into 28, remainder 1, 2, 42. And then obviously then I can scale it back up to get 100% by timesing by 10. Oh, no, 42, I've written the answer there. So obviously the answer is the 420. So you should get 420. Yeah, that's the thing. If I had a calculator, what I would have done is I would have done 294 divided by 0.7. The reason why I didn't do that with non-calculators is because I just didn't want to divide by decimal. If you're happy to divide by decimal, then you can also do it that way. But either way, you should get 420. Okay, I think that was it on that page. Question 10, a lot of the time we've got some kind of probability tree. Now, whether that is going to be probability trees, here is question 10, is quite early on in the paper, so this is a fairly straightforward one, or whether it's at the end of the paper being a harder question, who knows, could be either. So there are only 4 red counters and 3 blue counters in a bag. Taylor is going to take at random 2 counters from the bag, complete the tree. Now, because Taylor is going to take 2 counters at random, that's not going to, she's not replacing them. Do you know what I mean? We're just taking 2, we're just grabbing 2. So there's no replacement there. Normally if they replace a counter or whatever the context is, they will tell you. Takes a counter and then puts it back and then takes another counter, for example. They haven't said that, so you're going to assume that they have just grabbed 2 counters at the same time, they haven't replaced any. So obviously the first one's fairly straightforward. We just need to convert the actual quantities into probabilities. So for red, it's obviously going to be 4 out of 7. I would make fractions, personally. It's 4 out of 7. Blue is obviously then the 3 out of 7. Those, these 2 branches have to add up to 1. The same with these 2 branches have to add up to 1. And the last 2 as well. Now, if I follow the red one, if I'm to pick another red, because I've already picked a red, you see I'd only have 3 red left, but also in the bag there'd only be 6 counters left. So that second probability is going to change. And then obviously because I picked a red one first, I still do have 3 blue ones, don't I? But again, out of 6. So that, see how that adds up to 1 as well. Now over here, if I pick a blue one, I would still have 4 red left, wouldn't I? 4 out of 6. If I pick a blue one, I've only got 2 blue out of 6, and again that would add up to 1. So that's the tree, 2 marks. Now you can kind of see the part B there. Work out the probability that Taylor picks at least 1 blue counter. Now if you've looked at my answer sheet, then you can see that there are 2 ways to do this. So again, if you do it a different way, that's fine, as long as you get the same answer. Normally what I would do is I'd highlight the options that satisfy the question. So at least 1 blue counter. We could have red first and then blue second. We could have blue first and then red second. But the other one to consider, because it says at least 1 blue counter, that means I could also have two blue counters, couldn't I? Blue and blue. So the reason why I say there's 2 ways to do this, do you see how I've highlighted 3 out of the 4 options on my tree? You could work out each of these individually, which is probably what I would normally just do, just to keep it simple. But that is obviously a longer method because I'd have to work out 3 probabilities. Or you could work out the only probability that it can't be, which is red and red. You can't pick up red and red. So you could work out red and red, but you'd have to remember to subtract it from 1, which depends if you want to do subtracting fractions. So there's 2 options there. I'm just going to work them out as they are. Obviously between our tree branches we always multiply because it's red and blue, blue and red, blue and blue. That's and rule, which is multiply. So 4/7 times 3/6. That would give me 12 over 42. Now I wouldn't simplify, I know that does simplify, I wouldn't simplify it just because we're going to work out a few others and at the end it's going to make it easier if they have. if they're left as they are. So blue and then red, so obviously 3/7 times 4/6. Now that is basically the same thing, isn't it? Just in a different order. Another 12 out of 42. And then blue and blue, 3/7 times 2/6 obviously gives me a slightly different answer, which is 6 out of 42. So the reason why I keep them the same and I don't simplify it is because I have to add them up at the end. If you have multiple options from your tree, you then always add them up, because we're saying it's either the yellow option or the green option or the blue option will happen. Only one of those three is going to happen. So the OR rule means add. So I'm going to add them. So obviously, because they have the same denominator, it makes it easier, doesn't it? Just add the numerators. You should get 30 out of 42. And you don't have to simplify it for your answer. You can if you want. Normally with probability, I know for Edexcel particularly, they don't really care if you simplify it or not. So I normally just kind of leave it for probability. And 30 out of 42 would obviously be accepted. Any different version of that would be fine. Okay, so just be careful because it is one where they don't replace the numbers. So obviously the second probabilities do change. Okay, question 11. This is transformations, but in the context of obviously shapes, not in terms of graphs. So describe fully the single transformation that maps triangle B onto triangle A. Now this is single deliberately. This, I feel like, happens quite a lot. You could, I mean, technically you could rotate it and then make it smaller, but the thing is they've asked for a single transformation. So whenever you see that something has obviously changed size, but has also flipped, has also kind of rotated, that is going to be an enlargement. Hang on, let me see. Yeah, 7 times 7 would be 49, which is if you did replace it, but we didn't replace it, so it's 6 times 7, which is 42, yeah. But yeah, you could do 1 minus 12 over 42 if you didn't want to work out all three separately. That's also fine. For the previous one. The other thing to be really careful of here is which way round they're asking, because I feel like naturally you want to go, well, A to B, but actually in this one, it's B to A, isn't it? So just double check which way round they want you to work it out as well. So we're starting at B, we're going back to A. So it is an enlargement, and I feel like, especially obviously for higher tier, a lot of the time it is an enlargement. So the enlargement is 1 mark. We then need to write just some information about the enlargement. We need to describe it. So you want to write a scale factor. So I just look at basically the two ones and go, right, that was, for example, that was 4 squares. This is now 2 squares, like the same side, isn't it? 4 squares and 2 squares. So A to B, well, B to A, we are actually halving it, aren't we? The scale factor is a half. But also the other thing to consider is the fact that it's rotated. That is reflected in my negative scale factor. Okay, so it is a negative scale factor, and that's quite common, I think, for Edexcel higher tier, is they do some kind of enlargement, and if it's flipped, it's by a negative scale factor. So that's the first thing. The other thing about what else can we say about an enlargement is the center of enlargement. So sometimes you can just look at it, but I think it's kind of hard when you've changed the scale because it's not exactly halfway between the 2 points. So what I would do in that case is probably just draw some lines. Grab my straight line. Draw some lines. Obviously match up the same corners, right? So that top corner of A is the bottom corner of B. And then this kind of corner of the right angle is the same as obviously this one over here. Just make sure you do match up the same corners. Now at this point you can already see where it's overlapping. So you can see wherever it overlaps, that's our center, isn't it? That's probably the easiest way to work it out. Center is 0 minus 1. Because it's not exactly halfway, because obviously not only does the shape, in this case, get half the size, it gets half as small, it also would get closer. To see how B would be twice as far away from the center as A. So it's not just about the size of the shape, it's also about the distance from the center as well. So you'd need those other pieces of information to get the 2 marks. Now, if you've been doing all of our recent lives where we've been going through past papers, cumulative frequency comes up a lot. It'll either be, I would say, most likely cumulative frequency, maybe box plots could come up instead. That's quite a similar topic, isn't it? But I think last year was actually a histogram. But, you know, it could be anything. But a lot of the time, I feel like it is cumulative frequency for a non-calculator. Again, this is just a prediction, so don't rely on this. But it is quite an easy topic to do without a calculator, so maybe that's why. So the table shows information about the profit made each day in a supermarket for 100 days. So you can see the frequency table. We now need to complete the cumulative frequency table for 1 mark. This is super, super easy. All you have to do is add up every time another row. So obviously the first row is the same. You see 0 to 50, 0 to 50, same thing. But then the second row is... Oh, I haven't even drawn that right. I'll have to edit that. These are meant to be zeros. I was thinking when I was about to say it and then it wasn't there. It's meant to be 0, isn't it? So 0 to 100 would include the first 2 rows. See how that would be 19? And then you add the next one, 0 to 150. Okay, so that would be 34 plus the 19, 53. So every time I'm adding another row, so that would be 78 and then 92. And then obviously the bottom row should add up to 100. So as long as your bottom row, if they've told you in the question the total, as long as your bottom row matches the total they've given you, then you know you've pretty much got it right. So that was for part A. We've then got part B, which I think I need to copy this. So let me just print screen this. Obviously on yours you'll be able to look at the 2 pages at the same time. But here I can't. So if they make you do the table, normally part B is then to fill out the fill out the graph. Not let me copy it. Okay, it's not letting me paste it, so I'll just have to kind of have it here. I can make that smaller. We'll put that there and let's move this over a bit. Okay, so what you actually have to remember though with this one is because it's a range, you are plotting the right hand side for the x. So where it says 50, that's where I'm going to plot on my graph. So 50 and then 6. Just be careful of all the scales. Okay, 50 and then 6. Then we had 119. Be careful of the 19 because it is technically then kind of halfway here, isn't it, between that square. Just be careful of that. We've then got 150 and 53. So 50's here, 53 halfway here. Then we've got 278. That one's even, so that's a little bit easier. 250 and 92. And then obviously the last one is 100, isn't it? 300 and 100. So your graph should always be increasing, right? It should always go up. Cumulative frequency should always be increasing. And now obviously you're going to try and join this up as best you can. A smooth kind of curve. Obviously do go through all the points. So I'm going to try and do it as best I can. Obviously on a piece of paper it's a bit easier for you to do it with a pencil, just in case you need to rub it out and try again. The reason why we want it as accurate as possible is because normally there's a part C, part D and so on where you need to then use it. Oh, that one's not so great, but hopefully yours is better than mine if you can do it on a piece of paper. Something like that. It should be a smooth curve, increasing. Now we have got a part C. So use your graph to find an estimate for the interquartile range. So we need to know interquartile range, we need the upper quartile, we need the lower quartile. So our total was 100, wasn't it? So the lower quartile is 25% of that, or 1/4 of that. So that would be 25, obviously that's quite a nice one. Again, make sure on your scale that you are going at the right place, so that would be there. So for me, obviously we're all going to get slightly different answers. I think in the answers PDF, I wrote a few different possible answers. Here we're going to have, what's that, 110, I got 115, I think one I drew on a piece of paper I got 110, you know, something around kind of 110, 120 is what I got. So that's our lower quartile. We obviously then need to work out the upper quartile as well. So that's at 75 again, make sure you put it at the right place on that scale, 75 there. To be fair, I think every time I did this graph, I've done it 4 times or so, I got the same answer. I got about 190, yeah, 190. So something around 190 is fine. Now, obviously, upper and lower quartile, we need to subtract those to get the range. So 190 minus 115, or whatever value you got, obviously subtract those. So that should give me, I think, 75. Now, I think one time I did get 80. So as long as it's something around 75, 80, you can see here our answer is obviously in pounds. So we get 2 marks for that. Now I do also have a part D on the next page, so we'll keep flipping back. So the part D, use your graph to find an estimate for the percentage of days on which the profit was greater than £220. So now this is then different because I'm going to use my x-axis for £220 and I'm going to go back to the number of days, which was the cumulative frequency in this context, wasn't it? So 220, let's come back to my graph. I'll get a different colour so we can identify that it's obviously different to my upper and lower quartile. So 220, again, be careful of the scale. 220 is 4 squares along from 200, so that's there. Up, and then now I'm going across. I'm going the opposite direction to before. So it depends on the question. There. Now, what does that give me? 84? Again, you might have a slightly different, you know, maybe 83, 85, kind of something around that. Now, if I come back, it did say greater. They do this quite a lot. They say greater than. So 84, in my case, was the number of days where it was actually less than 220. So what I need to do is take my total 100 minus the 84, because that will give me how many days was actually more or greater than 220. So just be careful. Have they said less than, in which case that would be your answer. Have they said greater than, in which case you'd have to do 100 minus. So 16. Now the other thing though is they have said they want it as a percentage. Now luckily this one is obviously a nice one because it's out of 100, so to make it into a percentage it's obviously just 16%. But that's the formula you would use if it was a different number. Obviously put the denominator as the total number, in this case it was 100, and then times it by 100 to get decimal. They probably won't use numbers that are too difficult if it's non-calculator. So yeah, that was a whole question. You got 7 marks. Question 13, I feel like there's normally some kind of straight line graph thing. This one is a fairly straightforward one because I got to the point where I didn't have really enough marks left in the paper, but it could obviously be more complicated than this. But something to do with straight lines, maybe coordinates. So the straight line L has equation 2y minus 3x minus 8. The point A has coordinate 7 minus 1. Find the equation of the straight line that is perpendicular to L and passes through A. So this is a really standard, straightforward question, right? On perpendicular lines. It's kind of the most straightforward you could get, I guess. So obviously a straight line, we need to know our gradient and we need to know our y-intercept. We need to know the gradient first. The gradient I'd normally obviously use change in y over change in x, but I don't have enough coordinates for that. So I'm actually going to have to do it a different way. That's why I've been given this equation here. So first of all, I need to rearrange the equation of line L to get y as the subject. So I'm going to rearrange that. So obviously add the 3x across. And then also, just don't forget you have to divide by 2. So the gradient is not the minus 3, right? You have to only pick out the gradient when you've got it as y as the subject. So do you see how in this case the gradient, the minus 4 doesn't really matter, but the gradient is positive 3 over 2. Now I would leave that as a fraction personally. So my gradient, which is m, isn't it? You don't have to write this, but I like to write that. M of line L is 3 over 2. Therefore, I can use that to create and find my perpendicular gradient, which is where we do the negative reciprocal. negative reciprocal. So it's positive, it will become negative, and then reciprocal, that's why I said leave it as a fraction, because then you can easily flip it. So that's actually the gradient of the line that I want. Now obviously all of our lines, every straight line is in this format. It might be rearranged, but it's in that format, isn't it? So I now know my gradient, so I can sub that in, negative 2/3 x plus c. The last thing I need to do is find the plus c. Now obviously they'll only give you information you need, right? So that piece of information we've used. The only thing left is the coordinates of a, which is where my line does cross through. So to find the y-intercept, I can just sub those in. Make sure you sub them in the correct way round. Obviously it's the opposite way to how they've written them in the coordinates. Now again, you just have to be really happy with fractions as well for this bit. So we'd have to multiply by 7. Multiplying by a whole number just affects the numerator, so that would be 14/3, negative 14/3. I would then need to add that to -1. So you might also want to convert -1 into something that has the same denominator. So -1 would be like the same as 3/3, wouldn't it? So then if I add 14/3, now I can actually work out c should get 11/3. Okay, so then that's it. Just write your answer obviously fully at the end. So we've got y equals negative 2/3 x plus 11/3. That would be your answer. Okay, so that's a really nice straightforward perpendicular lines question. Now question 14, we've got here express 0.384 recurring as a fraction, so obviously recurring decimals to fractions. So I'm going to start by putting x is equal to whatever decimal they happen to give you. You then have to figure out if you need, different versions of 10x, maybe 100x, maybe 1000x, so on. Depends on the number, doesn't it? Now, the first thing I want to do is isolate in my decimal just the recurring part. So you see how the 3 does not recur? So I'm actually going to move that out of the way. So I, in this case, would use 10x, just because that will move the 3 out of the decimal. So I can isolate the recurring part. Now that I've isolated the recurring part, I do need to have 2 versions of that equation, with not only obviously having the recurring part isolated, but also the same order of the recurring decimal. So I would need to multiply by another 100 to make it another version of the same decimal, wouldn't I? So obviously this side would become 1000, because 10 times 100 is 1000. And this side would become 384.84. Do you see how I've got the same exact recurring decimal in the same order? Once you've figured that out, it's then easy from there. We just need to subtract. So obviously you get 990 on this side of the equation. The other side, the whole point is that these will cancel the decimals. But just don't forget, you also need to subtract the 3, so that would be 381. Now from there, we just want to solve it. So you get x on one side, obviously divide by the 990 or whatever number your question happens to have. Now, because mine hasn't said to simplify, you could leave your answer like this. If they tell you to give the most simplified answer, then obviously you would have to simplify it. I haven't said that in this one, so they would be happy with 381 out of 990. That would be fine, but I think you can, if you did simplify it, it does simplify also to 127/330. You could write that. That's also fine. So some kind of equivalent of 381/990 is fine. Okay, question 15, algebraic proof seems to come up a fair amount in the non-calculator. Obviously it could come up randomly. The actual question itself is very varied. So this is just one that I've come up with. So prove algebraically that the sum of the squares of an odd number and an even number is always one more than a multiple of 4. So that's a lot to take in. The way that I work out algebraic proof, most of the time, it depends on the question, but most of the time, is in 3 steps. What numbers am I starting with? Now, if they give you some kind of algebra thing anyway, that's obviously what you're going to start with. But in this case, it's an odd and an even number, isn't it? So algebraically, I need to write those down. I can't just choose an odd number and an even number, right? That doesn't work. You have to do it algebraically. So you could write for an odd number the definition of an odd number the most standard one is 2n plus 1. Any version of that, you could do 2n minus 1, you could do 2n plus 3, like that's fine, any kind of version of this. The reason being because 2n is the algebraic definition of an even number. Anything, if you take any number and you multiply it by 2, it becomes even, doesn't it? So then, if that's my base, even, if I then add 1, think about number line, if you've got an even number, the next number along, or the number before it, if you minus 1, is odd, isn't it? So any version of that is fine. I normally use 2n plus 1. And obviously then for my even number, I use 2n. So you could use 4n if you want, it doesn't really matter. So that's my step 1. What numbers am I using? Step 2 is then what was the actual calculation? Like, what do I need to do with that? And in this case, it's the sum of the squares. So I need to write that. Sum is obviously plus and then squares, squaring it. So squaring it like this, squared, squared, and then add them. Now just be careful here, this is double brackets. It's not just 2n squared and then 1 squared. It's like you have to expand it all. So I feel like algebraic proof a lot of the time is just a lot of expanding at the start. So even if you're not necessarily sure what you're proving, just start expanding. Obviously this would become 4n squared as well. So I'm going to expand everything. I'm still not even worrying about what I'm proving until right at the end. So expand everything, simplify it, collect the like terms, all of that stuff. 4n squared plus 2n plus 2n plus 1. Just be careful that is a 1 at the end. Plus the other 4n squared. Now I'm going to collect the like terms. I get 8n squared plus 4n plus 1. So that's step 1 and step 2. At this point, you'd get 2 marks out of 3. So even if you weren't sure how to actually do the proof at the end, that's still 2 out of 3. So that's pretty good. Obviously then my step 3 is to actually answer the question. What am I trying to prove? I'm trying to prove in this case that it's always 1 more than a multiple of 4. Now, algebraic proof, again, depends on the question, but I think a lot of the time is some kind of factorizing at the end, and you just factorize depending on what you're trying to prove. So what I would do here is I would factorize out 4 because I want to prove it's a multiple of 4, but I'm only going to factorize it out of the first 2 terms. The reason being is because then I get this plus 1 at the end. Do you see how this bit here, if I do, it doesn't matter what's in the brackets, if I then times it by 4, by definition that's a multiple of 4, isn't it? So that bit there is a multiple of 4 in any case, whatever number you sub in, will always end up being a multiple of 4. And then if I add 1, do you see how that's then 1 more? 1 more than a multiple of 4. So that's how I would factorize that one. So that would be the proof. That would be 3 marks there. Set up your question, obviously expand, do whatever calculation they want you to do, and then do some kind of factorizing to prove it. Okay, question 16. I've seen a lot of cones, maybe spheres, hemispheres, cylinders, that kind of thing in the non-calculated paper, which might be surprising because obviously it's kind of a complicated formula. But obviously if it's non-calculated, they will not make you work out pi unless they say estimate. So question 16, the diagram shows a solid shape. The shape is a cone on top of a hemisphere. So the thing about Edexcel particularly is when they give you a hemisphere, the formula they give you is the whole sphere. So just be really careful, you have to remember that. They've given me the formula for the whole sphere, I'm going to have to half it at some point. So just be aware of that. Then we've also got that the base of the cone has a diameter of 8 centimeters, and the hemisphere obviously also has a diameter of 8 centimeters. This is also very common as well in Edexcel, is that they'll give you the diameter because obviously in the formula it is the radius. Because technically just subbing values into a formula is really basic, it's quite easy. So that's why they've added these kind of extra layers of just remembering it's half of a sphere, remembering the diameter, we need to half it to get the radius, things like that. So it's just about the details, this one basically. Then the total volume of the shape is 96, obviously pi centimeters cubed, so they're actually going to give it to us in terms of pi. We need to then work out the height of the cone. So I'm going to create a formula for the volume of the whole shape. So that would obviously be, maybe if I start up here, a third, so that'd be the whole cone, right? Third pi r squared h plus, now this is the bit, plus the hemisphere, so obviously the sphere is 4/3 pi r cubed, but then I would have to divide that by 2, so just remember that. Now that equals obviously the total volume. So now I can sub in the values that I do know. Just remember, you can always draw it on your diagram if you want. The radius is 4, not 8. So subbing in 1/3 pi 4 squared h. I don't know h, so I'm just going to leave it as that letter, that's fine. And then 4/3 pi 4 cubed over 2. Now, that also, though, I can actually put that as equal to 96 pi, can't I? Because I know that it does equal 96 pi. Now, normally one of the first things I'd do, especially if it's non-calculator, is the fact that all 3 terms have pi, so you can just cancel it out immediately. You don't need to worry about that. And now let's start working it out. So 4 squared is 16, obviously times by 1/3 doesn't actually, I wouldn't write that as a decimal. Leave it as a fraction, 16 over 3 pi. Plus, now this one we need to simplify. You might simplify it differently to me, but as long as we end up with the same thing, it's fine. What I did was 4/3 divided by 2. That actually simplifies to 2/3. Also think about half of 4/3 is going to be 2/3, isn't it? And then I did 4 cubed, which is 64. The reason why I did that is because I didn't want to have to times 64, I guess, by 4. But it's up to you, however you want to do that. Obviously equals 96. So now if I multiply that fraction, it doesn't divide by 3, so that would be 128 over 3. Now what you could do is you could move the 128 over 3 across. But what I actually did was, because they're both over 3, I just thought I'd rather actually just times everything by 3. That was my choice. You might not want to make the numbers any bigger, so you might not want to do that. But I just times it by 3. So this one times by 3 is 288. How do I find these types of volume? As in, do you mean how do you find them to practice them? Or what do you mean by how do you find these types of questions? You can obviously, if you're doing Edexcel, just scroll through every paper until you find a volume question. That's quite obvious because I'll obviously normally draw the shape. And then you can practice those. You can obviously go on to either Maths Genie and type in volume and look at those questions. You can obviously type in to the other website I think is quite good. It's called First Class Maths. That's quite a good one. And just, again, just go through the list of topics until you find volume of a sphere, volume of a cone, that kind of thing. They'll have loads of questions. Or yeah, just go through the past papers and, you know, keep checking through the past papers until you find these questions. They're quite obvious to find. And you will be given these formulas, right? Because they're not prisms. You will be given these formulas. As you can see, they'll be printed on the question itself. So this is as far as I've got. Obviously, I just now need to solve for h, don't I? So I'm going to take away the 128, which gives me 160, and then that's pretty straightforward from there. Divide by 16 gives me 10. So that was the answer. So it's effectively setting up the equation, and then it's just like rearranging in this question. Now that one I think I gave you extra. It was on the next page, but that was 4 marks I wrote for that one. 4 marks. Question 17, there's quite often some kind of, not necessarily inverse proportion, but proportion generally in the non-calculated question. So I've just gone with inverse proportion. So y is inversely proportional to x cubed. We obviously get given our matching pair and then the question. Normally I split these questions into 3 parts. So step 1 is, and again they've laid it out in 3 parts. I mean, step 1 is that first sentence, which is writing a formula. So that's obviously the inverse proportion formula, which you have to memorize is k over x, or in this case obviously k over x cubed. If they've added any other kind of details, you need to put that in your formula as well. Step 2 is then the matching pair, right? Sub that in so that I can find the value of k. So 15 over 2 is equal to k over 2 cubed, which is 8. Now I will just solve this for k, so I'm going to cross multiply. Well, just cross multiply by the 8. Actually, you don't need to cross multiply by the 2, but you can if you want. I would just do, that's basically 15 times 4, isn't it, which is 60. However you want to work that out. Again, we all work things out differently as long as you get 60. Now, normally I would then rewrite my formula with that number. So instead of k, it's obviously 60. Now, finally, step 3 is to actually answer the question, isn't it? So answer the question, now that you've got your formula, find the value of x when y is 20 over 9. So sub that in for y. So sub it into the right one. And now, do you see, all I need to do is just solve it. It's just basically algebra, this question, to be honest. It's basically just algebra. Now, the only thing with this is that some people think you need to divide by 60. That wouldn't work because you still have x cubed in the denominator. So in this case, you can, well, in any case, really, you can move the letter you're solving for, that's fine. So for this one, I would actually cross multiply to get rid of the fraction. So I'd move the x cubed out of the denominator by multiplying it, and then I would times 60 by 9, so 6 times 9 is 54, add a 0. And then from there, what I did, you can obviously divide by 20, but I just kind of knocked off the zeros for dividing by 10. X cubed would be 27. Now, the non-calculated papers, they will not make you square root or cube root anything that is not already a square or a cube number, so you need to recognize that 27 is a cube number, and when I cube root it, I get 3. That's just something you memorize, basically. So your answer is 3. Yeah, x is 3 exactly. Okay, question 18. Obviously, we've got kind of a more complicated indices question, some fractional indices as well. So this one, we need to work out the value of a and the value of n. So what I do with this is that on the left-hand side, I am going to use my index laws just to get rid of the brackets, kind of expand everything out. The index law is where you multiply the powers. Now, just be careful with the a at the front because that's just a number. Technically, that's a to the power of 1, isn't it? So when I multiply the powers, that would be a to the power of 2/3. Some people would just do 2/3 times a. Oh, the cone question was 4 marks. It was on like the next page because I gave you a bit more space. The cone question was 4 marks. So I would expand that, and obviously then the x as well. N times by 2/3 is either 2/3 n or 2n over 3, however you want to write it. The other side, I don't need to, simplify anything, do I? Once I've done this, then I want to, because I've got a and n, I need to have 2 separate equations, right? Because I've got 2 different values, 2 different letters. So what I do is I look at it and go, well, I mean, the most obvious thing is that the x term here must be this x term here, mustn't it? And then a, because a represents just a number, that's just a number, isn't it? Which is the same as the coefficient on the other side. So do you see how I can create these 2 equations separately? So I'm going to separate them now. A to the power of 2/3 is the same as 16. And then separately, x to the power of 2n over 3 is x to the power of 4. So you can then just solve them separately. It doesn't matter which order you do it in this case because they don't overlap. Sometimes they have, one of them might have both letters in, so you'd have to work out the other one first. It just depends. So this one, I need to take my power, my fractional power, and translate it as in not as a power. I'm basically saying that the root, the denominator 3 means cube root, so that's the cube root of a, and then squared, that's basically what's happened to a, isn't it? If I write it like that, do you see how I can undo it? So I would obviously square root 16 again, obviously it has to be a square number in order to square root it, and then I would cube both sides, so that's 64. So a is 64. And then for the x one, obviously we're working out n. If I've got x to the power of something is equal to x to the power of something else, at that point I can literally just compare the powers, like make these into an equation because the x's are kind of irrelevant. So I get 2n over 3 is equal to 4, and then you just solve that. So 2n is 12, n is 6. So you should get 64 and 6, okay? It seems like a lot of work for 2 marks, but based on the question that I, saw in the previous past papers, they gave it 2 marks. So yeah, that's why I went with 2 marks for that one. Question 19, we have algebraic fractions. In this case, it's come up as simplifying. So when you simplify algebraic fractions, you're going to try and factorize as much as possible, and then see if you can cancel out any of the brackets. So the numerator, there's 2 ways to factorize it. You can just factorize it into 2 brackets, or you could recognize that they have a common factor, all 3 terms of 2. So it doesn't really matter. You'll end up factorizing the 2 out either at the start or at the end, either way. So I would factorize out the 2 probably first. That's just what I would do. Now the denominator, I want you to recognize, is difference of 2 squares. Difference of 2 squares will come up at some point in one of your papers, and sometimes on its own, sometimes as this one is part of another topic. So you just have to recognize it. Now you can factorize it as it is, but I would probably pull out the 4 because then underneath I still have difference 2 squares. Now doing that, do you see how I could cross out that 2 and then this one would be simplified to a 2? So you could do that initially if you want. Now I'm going to factorize this. Obviously I've got x in both brackets. It's quite handy because then I don't have to factorise one where 2 is the coefficient, isn't it? It's a bit easier. Obviously, multiplying to make a negative, so plus and a minus. Factors of 15 that add up to 2 would be 5 and 3, but I want minus 2, so minus 5, positive 3. And then in the denominator, I still have this 2 here. Difference 2 squares factorises, you just square root both, and then put a plus and a minus. And now do you see how we've got 2 of the same? So we've got x minus 5 over, you can expand that denominator again if you want. Because I've not specified how to leave it, you can leave it like this, or you can expand it again. It's up to you. So x minus 5 over 2, and then x minus 3, some kind of equivalent of that is fine. It won't simplify any further. Okay, question 20, we're now getting into the slightly bigger questions at the end. So we've got some surds now. Write 3 over root 6 minus 5 root 2 over root 2 minus root 3 in the form a plus b root c over 2, where a, b, and c are integers. So, two things about this. Obviously, they've made one single fraction. That's one thing. We're going to have to subtract the fractions. But the other thing is that the denominator they have has no surds, which is quite common. Whenever you have fractions and surds, it's normally going to be some kind of rationalizing, isn't it? Now, in this case, we've got both types of denominator, so we have to rationalize in 2 different ways. Well, they're kind of similar, but slightly different. So to rationalize, I would probably start by rationalizing before I subtract them. To rationalize that denominator when it's just a single surd, you multiply by both the top and the bottom by the same surd. That's pretty straightforward. Now the second one, because you see how it's got 2 terms, it doesn't matter that they're both surds. It could be one surd and one number, like a whole number, but the fact that there's 2 separate terms means I need to rationalize it slightly differently. So it is going to be multiplied by the denominator, top and bottom. The only thing to remember is that you have to change the symbol. So if that was already minus, mine needs to be a plus. So just remember that it actually relates to difference of 2 squares, which is, we effectively factorised difference of 2 squares previously. Now we're going to expand difference of 2 squares. So I'm going to expand all of this or multiply it. Obviously the first one, 3 root 6 over, and then that would cancel to become 6. Now this is in the numerator kind of like single brackets. If you want to write it out in single brackets and then the denominator in double brackets, you can do that if that makes it easier to visualize. But effectively, just make sure you're multiplying the correct thing. So obviously our whole numbers are separate to the surd. So that would be 5, and then the root 2 times root 2 would cancel to become just 2. And then this one would be also another 5 on the outside, but it wouldn't cancel, it would become root 6. And then in the denominator, you don't have to expand this fully, but I'll just show you. Obviously root 2 times root 2 cancels to become 2. And the middle terms we get plus 2, we get plus root 6. And then the other one is then minus root 6. This is why we needed to have the 2 different symbols to create that plus and minus scenario. And then obviously at the end, just be careful at the end, it's always going to be a negative answer, so minus, and then it will cancel out to, in black, it will cancel out to become 3, minus 3. The reason why we do that is because then these surds that are left over will cancel out as well. So you don't necessarily have to write out those 2 surds in the middle if you don't want to, if you already know they're going to cancel. I'm just doing it to show you. So if I simplify this surd, that would become root 6 over 2 minus 10 plus 5 root 6 over, and then that would be minus 1. Just be careful at the bottom, that is minus 1, isn't it? There are 23 questions, so after this one there's 3 more. Now that I've actually rationalized it, I'm actually going to focus now on subtracting them, because at least my denominator are a little bit easier to find a common denominator. So I would probably, first of all, I would bring out this negative and make that a positive. That's something else I would do. And then I would just multiply the second fraction by 2. So the first one can stay the same. This becomes plus, and then multiply all of that by 2. So 20 plus 10 root 6. Obviously the root 6 is not affected because it's a surd, not a whole number, over 2. Now I can actually add them. So that would be 20 plus 11 root 6 over 2. And then that doesn't simplify. And also I know, because if I come back and have a look at how they put it in the format, it was something over 2, wasn't it? So I know that that's the most simplified answer. See here, we've got 4 marks. That was the answer. 20 plus 11 root 6 over 2. Okay, 3 more questions. So question 21, we've got circle theorems. So we've been told, obviously, angle BAC is 38, angle ADB is 74. A, B, C, and D are obviously points on the circumference of the circle. EAF is a tangent to the circle at A, and BCE is a straight line. So that one there is a straight line, but it's not tangent, is it? It's cutting, well, effectively cutting through the circle, so it's not tangent. Work out the size of angle AEC, A to E to C, so this one. So we're going to be working kind of our way towards the left. Now, circle theorems, there's normally a few different ways to do it. You might have used different circle theorems to how I'm going to do it, which is fine. But as long as you get the same number at the end, then we can assume it was correct. So I, first of all, saw if you ignore this line AB, then that's a cyclic quadrilateral. So technically I could work out this angle over here. So that'd be BCA. And that's obviously, in a cyclic quadrilateral, you do have to subtract them from 180. They add up to 180, don't they? That'd be 106. Because of the cyclic quadrilateral. From there, I then basically said, well, I can obviously work out, being that it's a straight line, the other side, because that will get me inside this triangle with the angle I actually want. So that's ECA is 180, then minus the 106 again, so obviously that's 74, isn't it? So now I've got one angle inside this triangle over here. Now that I've done the 74 and I've kind of worked with that, I could then look at the 38. There's a couple of ways of doing this. What I thought of was, obviously we've got a tangent and then these triangles, which creates the scenario of alternate segment theorem. So you can use it in 2 different ways, but what I did is I said, well, this whole side here is 106 because of alternate segment theorem, and then therefore I could work out the other side of that straight line. Obviously a tangent is a straight line, so that's basically what I did. CAE would be 180 minus the 38 and the 106. So if you add that, you get 144, take it away, you get 36. And then now we're just not even circle theorems anymore, it's just a triangle, isn't it? So finally, to work out AEC, I'm just going to take away from 180, because it's a triangle, 74 and 36. So 180, well, actually I'll work that out myself. When you add that, that makes 110, obviously take it away, you get 70. So your answer should be 70 degrees. So if you did it a different way to me, that's fine, as long as you did get 70. And that was 4 marks. Okay, 2 more questions. We've now got functions. Again, this is something that comes up quite a lot on the non-calculator paper. So we've got 2 questions here. So we've been given the functions f and g are such that f of x is ax plus b and g of x is 2x minus 10, where a and b are constants. So we've then been told this equation here that f of g of 7 is equal to 10, and then the inverse function of g of 4 is equal to f of 2. So we've got 2 equations, and because we've been asked to find the value of a and the value of b, that's effectively, I know it's functions, but effectively this is simultaneous equations, isn't it? Even though I know it's disguised by being functions, it is simultaneous equations. So I need to basically just work these out and set them up as equations. So first of all, working out this composite function, actually what I can do is I can work out sub in 7 to g, work that out, and then sub the answer into f. So that would be 2 times 7 minus 10, which is obviously 4. Then that would be subbed into f, wouldn't it? Now, obviously, I know I don't have a and b, so I could write it as 4a plus b. And then, because I know that answer does actually equal to 10. So that's my first equation. just going to leave that there. And then I'm going to look at my inverse function. Obviously, I need to find the inverse function of g. So normally we put y, don't we? Now, some people would swap x and y first and then rearrange it. I just rearrange it and then swap it at the end. It doesn't really matter. So I would add 10, I would divide by 2. So obviously then my inverse function of g, swap it back. So there's obviously not a y in your answer. X plus 10 over 2. Now though, I have to sub in 4, don't I? Because they've told me g, the inverse function of g of 4. So 4 plus 10 is 14 over 2 is 7. So that's one side, but then I also have the other side, which is when I sub in 2 to f. So do you see how that would be 2a plus b, and then 7 is equal to 7. So here are my two equations. Now, after all of that, you can forget about the functions, because now it's literally just solving simultaneous equations. They are also linear. So that's quite nice. So because we both have already got b as, 1b, 1b, same amount of b's, I'm going to use elimination method and same sign, subtract. So subtract both equations, we get 2a is 3. Then obviously solve it to find a. So a is 3 over 2, or 1.5 if you want to write it as a decimal. Now that I found a, I'm going to sub it back in to find b. I'm going to choose the second equation just because it's smaller. Doesn't really matter though, you can choose whichever of those two equations you want. Obviously 2 times 3 over 2 is just 3, isn't it? So that's fine. And then I can solve for b. b is 4. That's obviously a 5-mark question, that one. So I find that simultaneous equations also comes up a lot in non-calculator in some format. Obviously here I've put it within a functions question. It could be on its own, it could be linear, it could be quadratic, it could be graphically. They've drawn graphs and you solve it that way. But some form of simultaneous equations seems to come up a fair amount in non-calculator. Okay, we're on to our last question now. So here is a rectangle and a right angle triangle. The area of the rectangle is less than the area of the triangle. So it's like an equation, but given that we've been told less than, it's actually an inequality, isn't it? So find the set of possible values for x. Okay, so I'm obviously going to use the context, area of a rectangle, area of a triangle. So I'm going to set up my inequality. So the area of my rectangle is obviously base times height or length times width, whichever you prefer. So I'm going to multiply these. So that's basically double brackets, isn't it? Now make sure you always get the symbol the right way around. The rectangle is less than the triangle in this case. So less than, so it's going to face the triangle. Now also be careful with the area of a triangle, because that is x times x, which is x squared, but remember it is over 2, or if you put a half. Don't forget, because obviously I know with the rectangle you don't have to do that, so just make sure you do put that over 2. Now at this point I can, just for now, forget about the context and solve this, and then at the end we'll think about the context again. So I'm going to expand and simplify and all of that. Obviously I'm going to end up with a quadratic, aren't I? Because again, this is 5 marks at the end of the paper. So expand it, 2x squared minus 4x minus another 4x plus 8, be careful with the symbols, and then obviously x squared over 2. Now I'm going to collect the like terms here, and then you can also double it. I would probably move that 2 across. So 2x squared minus 8x plus 8, and then I'm going to actually times everything by 2 on the left side, so that's 4x squared minus 16x plus 16 is less than x squared. Now because it's obviously a quadratic overall, the highest power of x is squared, so it's obviously a quadratic. I'm going to have to solve it by just moving everything to one side. Normally I choose which side to move everything to is where the x squared will remain positive, so I'm going to move the 1x squared, going to take that away, because then I still have a positive x squared, so when I try and factorize it'll be easier. Okay, so now I'm going to factorize this, so 3x, I'm probably just going to do trial and error in this case. You can do splitting the middle term method if you want, but for the AC method I'm just going to do it because 3 is not too complicated a number. Now obviously we're multiplying to make a positive, but when I add them they're negative, so they're both going to be negative, so that's a bit easier as well. Factors of 16, that when I multiply 1 by 3 it would make 16 as well when I add it. Okay, so I think we get 4 and 4, because if you do 3 times 4 it's 12, and then obviously the other 4, 16. So solving that, I would just put x, I'll put it equal to, and then we'll put the inequality back in at the end. So that's positive 4/3 or positive 4. Now, the only thing with this though, so let's actually, before I say that, let's put this into the inequality. Now, I mentioned in my live in the previous live today, the Q&A one, that you can just memorize if it faces the quadratic, it means this type of inequality at the end. If it faces the 0, it means the other type. Because it's facing the 0, it means a range. So technically, x is between, obviously 4/3 is smaller, isn't it? So 4/3 and then 4. That's technically what x is between. Now, what we have to do though is come back and remember that this was, there was a context, it was shapes. So you have to double check of my answers, do they work? So 4/3 and 4, if I come back here, I'll write it up here. We got x is between 4/3 and 4. Can that actually be true for the context? Because obviously, think about it, you can't have a negative side length. So obviously the triangle's fine. It could be 4/3 and 4/3. It could be 4. It could be anything between. The triangle's fine. I'm thinking more of this rectangle where I've got some subtract. If I did 4/3, think of 4/3 as a decimal. It's like 1.33333. If I take away 2, that would become negative, wouldn't it? The 4 would be fine. 4 minus 2 is 2. So 4 is fine. But the 4/3 would be too small. And the same if you subbed it in here. That's basically, I mean, those are basically the same sides, aren't they? So the only thing to be aware of, sometimes it's probably a bit easier than this one. Normally it's just if one's negative, you just choose the other one. But in this case, because we have got an inequality, we need to still have a range. So I need to figure out what would be the smallest possible value of x before it then becomes negative. Now, that would be if I just take one of those sides. It can't be 0, well, it can't technically be 0, but it can't be less than 0, can it? So you see, if I solve that, do you see how that gives me 2? The smallest value of x I can have is 2. Obviously, I wouldn't have 2, I'd have something more than 2. But therefore, my lower limit would actually have to be 2. So this one's a little bit more complicated, that's why this is the last question on the paper. So my actual final answer would have to be x can be between 2 and 4. It can't be as small as 4/3. 4/3 is too small. Obviously, we need an inequality as the answer. They said set of possible values. So yeah, that was a bit trickier to figure out the smallest value that x could be, because none of them were negative in terms of themselves, so it wasn't as obvious, was it? But yeah, so that one was also a 5 marker, obviously. 5 marks. So your answer should be x is between, I'll write that there so we don't get confused. Final answer, x is between 2 and 4. Okay, and that was, pretty sure, the last question on the paper. So that was my best attempt at writing a predicted paper. Hopefully you found it helpful. If not, obviously then just use the past papers, but that was just me trying to make up a past paper that was somewhat representative. Yeah, hang on, let me go back through the last bit again. But yeah, otherwise, for everyone else who has finished watching it, then thanks for watching. If you want to find this paper and my answers, I have linked the Google Drive down below as well, and I've also linked in the description of this live all of the topics that I've got videos on myself that are on this, so you can always go back and have a look. And if you've got any kind of more questions about each topic, you can have a look through my videos as well. Otherwise, we will have our next live on Sunday, which will be a Q&A at about 4:30. Before next week, we'll have a few more, obviously, during the week before your paper one as well. I don't have a website. I'm thinking of making one for next year, though. I know that you're doing it next year, right? So I might have a website by this time next year, maybe. But currently I don't. It's just literally this YouTube channel, basically, is where everything is. Yeah. Hang on, let me go back here. Yeah, here we are. Yeah, this one's obviously I've written it myself, so I kind of tried to make the numbers make sense as much as I could. It's quite hard to write down, create all of these questions from scratch. But yeah, so normally when you've got a context, I think the Edexcel version might be a bit easier than this, to be fair. normally, obviously with a quadratic, you always get 2 answers. Normally when there's shapes involved, they normally ask you to choose one of the answers. That's if it was an equation, if it was equal to, you'd obviously ignore the 4/3 and you'd say 4. Because this is actually an inequality, we still need to have 2 values. We still need to have a range of possible values for x. So I had to figure out 4, when I subbed it into x and x for the triangle, absolutely fine. I can have a side length of 4, can't I? That's fine. It's the rectangle that's the problem. If I did 4 times 2, that's 8 minus 4. I get 4, still positive, absolutely fine. And if I do 4 minus 2, that's 2, still positive. So my 4 digit was fine. That was fine. I could use that. That's valid for shapes, isn't it? The problem is if you think about 4/3 as a decimal, if you think about what it is, it's 1 and 1/3, isn't it? So if I then subbed that in, do you see how I would get, if I did 4/3 minus 2, it would be minus 2/3. I can't have minus 2/3 as a side length. That's impossible. I can't have that, right? And the reason why I didn't really bother with this side is because technically, if you halved it, it's the same as the other side. But if you had 2 different sides, you would check both, right? But because they basically simplify to the same thing, I didn't worry. So what I was realizing is that 4/3 is invalid. It's too small for the range. X can't be 4/3. So then I had to then go on and figure out what is the smallest possible value that x can be. So using that same side length, obviously my sides can't be negative. They also technically can't be 0, but they can't be negative. So, and because my inequality is not equal to, it's greater than, less than. I said, right, the smallest value it technically could be is 0, which I know it can't be, but you know what I mean? It could be 0.1 and that would be fine. So I went with 0. So I said this side, the smallest it could be, I guess if you want to put it as an inequality, it has to be greater than 0, doesn't it? So then x has to be greater than 2. So 2 was my smallest value. That's the kind of explanation bit. So therefore I had to choose 2 and 4. X could be anywhere between 2 and 4 and that would be valid. For not only having positive side lengths, but also in having the fact that the area of the rectangle is still less than the triangle. So yeah, that's that paper. The predicted papers, what I will be doing is I will be writing my own predicted paper 2 and paper 3. Obviously though, that those exams are in June, the actual exams. I know you're not doing it this year, but for everyone else who are year 11 this year, those predicted papers I will do ahead of, so like end of May, start of June. So that won't be for, I mean, we're start of May right now, so it'll be, you know, probably in 2 or 3 weeks, the next predicted papers will come out, okay? So just this one for now, because obviously the non-calculated paper the exam is a few weeks before the other 2. But otherwise, if you have any other questions, please leave them down below in the description. And as I said, I've actually filmed a video going through this kind of, I've edited it, right? So it's a bit shorter than this one that's currently an hour and a half. It'll be probably about 50 minutes, an hour long. So that one will upload on Monday. So if you want to go through it in kind of more of like a succinct way, you want to skip ahead to different questions, I will upload that video going through this exact same paper on Monday anyway. But otherwise, thanks for joining us today, guys, and I'll see you on Sunday.